All right, so what you're going to learn today is how to read the graphs of parabolas. Okay, remember we said a parabola is the graph of a quadratic equation, remember? So a parabola looks something like this, right? Remember we said it's a U shape. We can have a U shape. So today what we're going to do is identify factors, roots, zeros, intercepts, and solutions to this quadratic equation just by looking at it. All right? So what you need to first know is, what does an x-intercept mean? An x-intercept means it's where the graph crosses the x-axis. So on your graphs, remember the x-axis is the horizontal one, right? So this parabola crosses this graph in two spots, here and here. So these are actually called x-intercepts. We've got two x-intercepts there. Now x-intercepts actually has three other names. Okay, so if I'm talking about an x-intercept, I'm talking about where the graph touches the x-axis. Okay, another name would be something like the solution. Remember last time when we tried to find the solutions in the graphing calculator, we said the solutions are where they cross the x-axis, right? And so we plugged it in our calculators, and then we found the answer that was here, and we found the answer that was here, right? So if solutions are these and x-intercepts are these, they're just talking about the same exact thing, okay? So an x-intercept is also known as a solution. It is also known as the real roots. So if you see this word real roots, they're also talking about where it crosses the x-axis. Okay? And then there's one more name. And the other name, the third name, is zeros. If they say, what are the zeros here? They're talking about wherever it touches right here, because this is where the y is 0, right? So that's what they want to know. So if I ask, what are the x-intercepts? Then you would give me these answers. If I ask, what are the solutions? You would give me these answers again. If I said, what are the real roots? You would give me these answers. And if I said, what are the zeros? You will give me these answers. So it just has many, many names. Just like you as an individual, if your name is Michael, for instance, somebody might call you Mike, right? But you still are the same person, correct? So you can have more than one name and be the same person, and that's what's going on here. So x-intercepts does have more than one name. So you have to remember that they all mean the same exact thing, okay? All right. So moving along, we're going to see questions like this where it says state the factors given the graph. So if you're given a picture of a graph, and this graph is called a parabola, remember, because it's a U shape, we could actually find the factors just by looking at the graph. Last time you learned that when you found the factors, remember factors look like this, right? X plus 3, X minus 2, or something like that. And then we said we could find the solutions because when we set each one of them equal to 0, what wound up happening is it was just the opposite sign. So x equals -3, right? So this would have been where it crossed the x-axis. Over here, the solution to this one, the opposite sign of a -2 would be a +2. So we could also say that that would be my answer. So we could actually work backwards. If we have the solutions to begin with, then we can work backwards and just change the answers of my signs, or switch my signs to find my factors. Okay, so let's do an example of that. So here are the steps. The first thing we're going to do is locate where the x-intercepts are. So remember, x-intercepts are wherever they cross the x-axis. Once we know exactly where they cross the x-axis, we're going to write out our solutions. Okay, then we're going to switch their signs, and we're going to write our final answer like this. And this is only if they're asking me for a factor. okay, because factors would be the opposite signs of whatever the solutions are, all right? Now this graph, unfortunately, I wish this would have been a better graph, sorry, but this graph, it's hard to definitely tell what the solutions are because they're not on an exact number, right? So we're just going to go ahead and say, let's say for example, here, I'll do this. Let's fix this graph. Let's make it kind of cross more like this so that's easier to read for us. So if I want the factors of this graph, the one in black, I just fixed it just to make it a little bit easier to read. Then the first thing I want to do is find the x-intercepts. So my first x-intercept would be here because this is where it touches the x-axis, right? So my first solution or my first x-intercept would be, this would be a positive 2. So I'm going to write positive 2. My other x-intercept over here would be a positive 6. And I know it's positive because it's on the positive side, okay? So positive 6. So I found the x-intercepts. I wrote them out down here, okay? Then step 3 says we're going to switch the signs. So if this is a positive 2 as one of my solutions, then I'm going to switch the sign and make it a negative 2. This is a positive 6 as the other solution. I'm going to switch it and make it a negative 6. Okay? So my answer, if I'm changing solutions to factors, would be to switch the sign and write the x's in front, right? Make them look like factors here. So if my solutions are positive 2 and positive 6, my factors are going to be x minus 2 and x minus 6 because all I'm doing is switching their signs, okay? And factors look like this, where they have the parentheses with the x plus, x minus, and so on and so forth. So we're going to do a couple more and make sure we got this, okay? All right, example 2. This one's a lot easier to read here. So if this said state the factors, if we see this word, state the factors, and they gave us a graph, what I want to do first, because I know factors are supposed to look like this, okay? What I want to do is find where right now it's crossing the x-axis. What are my x-intercepts? So my first x-intercept is right here, and this is actually negative 2, right? 2. And then the other one here at the origin, and the number for the origin is 0, okay? So I have 0. All right, so what I want to do is then switch the sign and put it in parentheses, okay? So if this is a negative 2, then my factor should be x plus 2. If this one here is a 0, 0 doesn't necessarily have a sign, right? So if we made this, what 0 means typically is that we're not going to have a different factor here, okay? Or this would have been because we had a GCF somewhere out there. So really the only factor that we're going to have right now would be this one right here, x plus 2. 0 winds up happening if we had something like this. And this is a little bit more difficult to tell because we don't have multiple choice. But for instance, 0 came as a solution when we had something like this, 2n parentheses n plus 2. So remember before, we would find the solutions by setting each one equal to 0. Okay, so we would make this a negative 2, and this one, because we would divide by 2, would give me a 0. So this is really here is what something with a 0 would look like, okay? But for now, the only factor that we can guarantee that we have here, because we really don't know what the expression looks like, but the only one that we can guarantee is that we at least have the x plus 2 or the n plus 2, because we know this one for sure, So we can just switch that sign and make it a factor, okay? All right, example 3. So again, I want to write the factor or write the factors. So based on this graph, to write my factor, I want to see where it crosses the x-axis first. So it's crossing in 2 spots. Right now here we have a -3, and this one here is a -1, right? So if I have -3 and -1, then my factors are going to be the opposite signs, and we put our x's inside, right? So this would be x plus 3 and x plus 1. And those would be my factors. So wherever they cross the x-axis, you look at the sign that they are currently, and then you switch the sign and put them in parentheses with the x. All right, next part. It says determining the number of real roots. Determine the number of real roots in each of the following functions. So what you have on your paper is just this part. F of x equals 2x squared plus 4x. Okay, so to determine the number of real roots again is another word for x-intercept. Real roots also mean solutions. Remember, these all mean the same exact thing. So if I'm looking for the number of real roots, I'm looking to see how many times they cross the x-axis. So what I would want to do is I would want to actually go ahead and graph this in my calculator to see where it crosses, okay, or to see how many times it crosses. So that's why you could see this picture here of the graph. So in your graphing calculators, you would put this into y equals. Okay, this part right here. Remember, this f of x is just a fancy way of saying y equals here. So if I put y equals 2x squared plus 4x in my calculator, and then I hit graph, because I want to see what it looks like, then this graph is going to pop up. So once I see the graph, in order for me to find the real roots, which means find the x-intercepts, I want to see where it crosses, okay? And this one just says find the number, so how many of these do I have? Well, how many times does it cross my x-axis? It crosses once here, do that in a different color, once right here, and it crosses another time right here. So this would have 2 real roots. They cross here and here, and there's 2 of them. So the same thing for B. If we are determining the number of real roots here, we want to know how many times it crosses the x-axis. So I would want to graph this in my calculator into y equals, and make sure you're putting the signs there, right? Negative 2a squared minus 12a minus 22. When you do that, remember before we said if the quadratic term is negative, then usually our parabola is going to be upside down. So if you graph it, it winds up looking something like this, okay? So there's a picture there. Now remember before we said the solutions, which are also known as x-intercepts, are wherever they cross the x-axis. So this graph here never even touches the x-axis, right? So do we have any real roots? Do we have any solutions? Do we have any x-intercepts? We do not. So we would say no real roots, or you could say there are 0 real roots, right? There are none. Because that one never even crossed the x-axis to begin with. All right, so letter C, again, we want to know how many real roots we have, right? How many times does this cross the x-axis? Or how many times does it cross the how many x-intercepts do you have? Sorry, x-intercepts. So if I'm going to graph this one, again, you're going to put that in your y equals. And this is just, again, a fancy way of writing y equals. So we're going to put y equals x squared and y1 plus 6x plus 9. So when you do that, your picture is going to look, of your graph is going to look like this. Now this one is kind of really hard to tell because you can't really see how many times it crosses. It looks like it crosses only once, but we just want to make sure. We can't really guarantee that. So what you can actually do when you're unsure of how many times it crosses is you can zoom in to your calculator. So you know that zoom button that's there? We could actually go ahead and press that just to make sure. So let me drag the calculator up so you could see how to press it. So I'm going to put in x squared plus 6x plus 9. If I graphed it, oh, let me put it back to the normal window first so I could show you. This is what it originally looked like, right? And we were not sure if it crossed once or twice or if it didn't touch at all. So you could always zoom in just to verify. The zoom button is right here, so you would press zoom, and zoom in is option 2. So you would press option 2. And right now, the little blinker is right here in the origin. It's at 0, 0. So I want to move it over to the left until it's kind of in the middle there, so I could actually zoom in and increase the size there, see it better. So once I have it where I kind of like it, so that I can zoom in there, I'm going to press enter. So this gave me a better picture. Does it cross 2 times or does it only cross 1 time? Well, it actually only crosses once. So that's this picture right here. So how many real roots do we have? We only have one real root. So you could have 2 real roots, no real roots, right, if it doesn't cross at all, or you could have 1 real root. You cannot have more than that, and the reason why you can't have more, so you could only have 2, 1, or none. The reason why you can only have a maximum of 2 is because this is a quadratic and your exponent is 2. So this exponent actually tells you how many you can possibly have. That's the highest number you can have. But you could have 2 or you could have less than 2 as well. Okay? So that's why we could either have 2 real roots, 1, or none at all. All right, last part of this. We're going to sketch a quadratic function given the roots. So this time it says sketch, which means to draw the quadratic function given the roots -2 and 3. So again, roots or real roots also means solutions, which also means it's the x-intercept. So this means that I should have points on the x-axis wherever the -2 is and wherever the +3 is. So this is my x-axis here. I want to count, make sure my coordinate grid is good. So I should have a point at -2, which would be over here. And I should also have a point at +3. Okay, and if they're talking about real roots and they said this is a quadratic, then the quadratic, remember, looks like a U shape, remember? So we're not going to draw a line here because this is not a line, this is a quadratic. So what we want to do if we're sketching, we don't exactly know how it looks, but we do know that a parabola usually starts up, comes down, and then goes back up, right? So it should look something very similar to that. So if they gave you the roots and they told you to sketch it, what you're doing is putting a point on the grid of whatever they told you, whatever values they gave you, and then you're going to draw a U shape, okay? Now, we can't guarantee that it's facing up. It could be facing upside down, right? But either one, as long as we can identify that the points have to be on -2 and they have to be on +3, and we also cannot have a line, okay? But we can guarantee it'll look something like this, okay? It's got to be U-shaped. All right, 2 more, and then we are done. So it says plotting the zeros on a graph. Given the following graph, identify the zeros. So remember, again, this word zeros, we have many different definitions. Zeros can mean solutions. It can mean x-intercepts or real roots. But really, we're always looking for the x-intercept, okay? That's what we're looking for. So identify the zeros. So where are my x-intercepts? Well, it crosses here and it crosses here. So what are these numbers? This is a -4, and this one here is a -2. So those are my zeros. So on your SOL, what you would do if they gave you a question like this is you would just take your mouse and you would click here and you would click there, and that would be how you would answer that, okay? Same thing for B. You're just identifying the zeros, so you're looking for where it crosses the x-axis. So you would take your little mouse and you would click here, and this is a +2, and then you would click here, and this is a +4, okay? Oh, I'm sorry, that is a +6, thank you. +6. I was thinking it was over the other way. Very good. All right, and that is it. So in summary, what we need to remember is that x-intercepts has many different words, many different other terms or definitions. An x-intercept is also known as a solution, a zero, or root or real root. Okay, so anytime you see these words in the question, they're all talking about the same thing. They're all talking about that x-intercept. Whenever they're asking you to factor or find the factors, you just find your x-intercepts, you switch the signs, and then you write them in factored form, right? So x, and then whatever these signs were go in here. Okay? So that's all you need to know for this.